Hi everyone, welcome back. Welcome to week 7. So I accidentally made a blooper and I added surjectivity onto week 6. So if you're just joining us for week 7, you could go back to my video, Injectivity and Surjectivity, to learn about surjectivity. Okay, so one piece of advice I wanted to give everyone was try to figure out the bare bones that you would need for a surjectivity proof or an injectivity proof. Okay, but today what we're going to be talking about is bijectivity. Okay, so once again, when we talk about bijectivity or if something is bijective or not, we really only mean if it's already a function. So something you might have noticed is bijective, it starts with the bi, which usually means two, so like bicycle. So a bijective function, f from x, y, so remember still when we're defining a function, we have to define its domain and codomain. So this will be a function that is surjective and injective. Okay, so it's two things. All right, so these are really special. So remember in my other video, I talked about how if you are injective, that doesn't mean that you are surjective or that you're not surjective, and vice versa. I mean, you can get into special things where if you know some information about the domain or the codomain, maybe you can start saying some things like that. I won't give that away because they're probably going to put that on the homework maybe or an exam or something. It's a pretty fun proof. But yeah, so if you know something more about the function's domain or codomain, you can start saying some stuff like that. But just in general, if something is injective, you can't necessarily say anything about its surjectivity, and vice versa. But if we're bijective, we know that we're both injective and surjective. So that's a pretty special function. So what I'm going to do now is I'm going to just launch into some examples of showing how to prove these things. Okay, so for our first example, we're going to look at an absolute value function, but notice we're going from r plus r plus. So just a reminder, r plus is the interval not including 0 to infinity. Okay, so I'm going to give a proof that this is bijective. Okay, so notice I shorten all these words a lot. I write S-U-R-G or I-N-G and B-I-G. It's just a lot faster because you'll use these words a lot in your mathematical life. Okay, so what do I need to show to prove that this is true? So if I'm doing a direct proof, well, I would need to show two things, that it's surjective and that it is injective. Okay, so it's kind of like showing that two things are equal. You want to show the subset both ways. So now I'm going to want to show the surjective side and the injective side. Okay, all right. So let's start with surjective. So we want to show that everything in the codomain gets hit. So everything in the codomain is in the range. So I just want to pick some random generic element from the codomain. Let's say let y be an r plus. And you don't have to do this, but I'm going to say codomain. It's just an added bit of information that you can give people to let them know that you know what you're talking about. You know, I don't think you have to do it necessarily, but if it makes you feel better, that's great. All right, so something about our element y being an r plus is that it's positive. So then y is bigger than 0, so the absolute value of y is just going to be y. So that's nice. Okay. All right. And y is in r plus as the domain. So since the codomain and the domain are equal, we're all good there, right? Then consider, f of y. So remember, the surjectivity, typically what we do is we do scratch work and we say, okay, so if I want f of x equals y, what do I have to do? Which x do I have to have to make that happen for me? Well, this one I didn't really need to do scratch work. If you want to, you can. So we have this. Sorry, my bunnies are trying to chew on my cords. Okay, so let's see. Therefore, so now remember I said before, we have to mention what the definition of surjectivity is or injectivity at any given time. Therefore, for all y in our codomain, there exists someone in our domain such that f of x equals y. So in fact, x equals y. So how cool is that? So, or you could say, namely, let x equal y. You don't have to add that in. That's kind of just like a fancy flair or whatever. But this last part, you do have to say this is still part of our conclusion that you always need to add. I remember when I used to be a grader for this class, that would be like 2 points. It was just writing a conclusion, okay? So a little helpful hint, even if, I mean, you would have to check with the instructor. I'm not sure if they're okay with this, but even if you don't know how to do the whole proof, you maybe like start it and stuff, you talk about definitions and things, and you maybe don't know how to do the middle part, you can at least write the conclusion. You can at least say what needs to happen. So we still need to show injectivity. So remember, my little trick of remembering injectivity is like, so if every element in the domain has a bow and arrow, each, and they all have to shoot their bow and arrow, right? Or else it's not a function. So in the codomain, each element, if it does catch an arrow, only catches one. Okay, so that's kind of how I remember that. And so from our first part, we know that every element in the codomain does catch an arrow, but now we need to just show that they only catch one. Okay, and we don't even need to be thinking about surjectivity while we're doing our injectivity proof. Okay, since we already proved it, we could use it to our advantage since we have them in this order, but I can't think of a way that would be advantageous. But just in the future of your mathematical career, there are times when you do stuff like that. All right, so we just want to consider two elements in our domain. And remember, we're trying to prove an if-then statement. So when we prove an if-then statement, we want to assume the if part and then show that the then part has to be true. So I want to assume that f of x1 equals f of x2. Okay, but what does that mean? Well, we actually know what f does to our element, so let's start talking about that. So we have that absolute value of x1 equals absolute value of x2. Okay, but now we can use some of the information we used above, how since x1 and x2 have to be positive, then their absolute values are equal to themselves. So if you notice that you were going to use this in your proof multiple times throughout your proof, you could have started the proof before even talking about surjectivity. You could have said, note that for any element bigger than 0, the absolute value of that element is equal to that element. Okay? All right. So now I want to say, so by this thing up here, right? Because wouldn't it be so much easier if I just like referenced that and then didn't have to say like, okay, well, since x1 equals absolute value of x1, absolute value of x1 equals absolute value of x2, blah, 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 blah. You know what I mean? Like, wouldn't it be so much easier if I just referenced that? So here's a way that we can reference it. So we usually reference it by an asterisk, or you can do a star. And if you want to do multiple references throughout your proof, your first one would be asterisk or star, and then your next one could be like star star asterisk asterisk, something like that. I would try to stay away from using asterisk and then star, just because it might be difficult for the grader to discern the difference between the two. Okay, so by asterisk, we have x1 equals x2. So all I'm saying here is I already did part of the calculation. Okay, so I have that these two absolute values are equal to each other, and now I just said that those absolute values are equal to themselves, like the element inside the absolute values. Boom, I'm done. Okay? Therefore, for all x1, x2 in our domain, such that f of x1 equals f of x2, then x1 equals x2. Or, so that is one way to say it. Excuse me. Or you could say, for all this implies this is true. Okay? Therefore, F injective. Ooh. Okay, so I wrote my conclusion for that piece of our proof, but I still need to say why F is bijective. f injective and surjective, then f bijective. Now we're done with the proof. Woohoo! So now let's start thinking about what would it mean for a function to not be bijective. So think about the negation of our definition of bijective. So to be bijective, you have to be surjective and injective. So remember, negation of an and statement is an or statement. So to not be bijective, you're not injective or you're not surjective. Okay, so we only have to show one of them. So it might be true that maybe some functions are neither. So it's not injective and it's not surjective. Okay, we could probably think of a lot of examples of that. But all we need to do for a proof is just show that it's not one of them. First thing we want to look at is try to figure out which one it's not. So for our luck, this one is neither injective nor is it surjective. Okay, so I could show you, well, actually, okay, so the next example I'm going to show it's not surjective. So for this one, I'm going to show it's not injective. Okay, but you could do either way. You could show that this is not surjective because, for example, it doesn't hit -1, and then you just want to talk about why it doesn't hit -1. Okay, but I'm going to show it's injective. So if we can picture the actual drawing of this, oops, you know, it's pretty noticeable that it's not injective, right? And then it's pretty noticeable it's not surjective. It's never going to go down here, okay? All right, but not every single function that you're going to be handed is going to be, are you going to be able to draw so easily? I'm going to consider maybe 1 and -1, because what's the negation of injection? Well, we're going to have two elements that are not equal, but the function sends them to the same thing. So I'm going to consider those in our domain. That R. Okay. We have that 1 squared equals 1 equals -1 squared. So f of 1 equals f of -1. But 1 does not equal -1. And you might be thinking, well, Danica, that's just obvious. Like, why can't the reader just get that? Well, you have to actually explicitly say that. Like, so we have that f of those two things are equal, but those two elements are not equal. You just have to state it. Therefore, f is not injective. By definition. Okay, and then somewhere in this, you should write the definition of injective by definition. Okay, since I already wrote the definition earlier, and I have the luxury of not taking an exam or a homework right now, I'm not going to write the definition again. Okay, but is that our conclusion? No, it is not, because we're trying to show it's not bijective. Okay, so let's finish it up. Since f not injective, then f can't be bijective. Woohoo! Okay, now we're done. Okay, so now for this one, we have a new function here, and we have x cubed. Ooh. So x cubed would allow us to get some negatives, but notice where our domain is. Our domain is only the positives. So still, we're not going to be bijective. And so this time, it's not because we're not injective, because actually, in this case, we are injective, okay? But we are not surjective, okay? All right, so proof. Okay, so if we're not surjective, we need to pick some element in the codomain that it does not hit. So one easy shooting fish in a barrel example is 0, but maybe I'm going to pick like -1 or something. So consider -1 in the reals. Oh boy, so now how do we show that this doesn't happen? Okay, well, let's say since f of x equals x cubed, but x greater than 0, then x cubed greater than 0, so f of x greater than 0 for all x in R plus. Okay. So if you notice, I'm just kind of doing like free thought here. Okay, I'm saying a bunch of true things. So recognize saying true things doesn't always get you moving forward, but in this case it is, because now I just showed f of x is always bigger than 0. It's always positive. Okay? Therefore, there exists no x in R plus such that f of x equals -1. So f not surjective. And then once again, you do want to include the definition of surjective somewhere. And it could even be higher up on your page. So like if you're on an exam and you see that the problem has to do with bijection, you can write bijection is surjective and injective. Surjection means blah, blah, blah. Injection means blah, blah, blah. You just want to get it somewhere, okay? And then even if you just jot those down and then you can't figure out how to do the proof, then at least you can get points for knowing the definition and knowing what you're supposed to do, okay? So f is not surjective, but that is not our conclusion. We still have to say why it's not bijective. Since f not surjective, then f not bijective. Okay, so that's the end of this video.